In this video, we're going to talk about the difference between a physical change and a chemical change. When a physical change occurs, the chemical identity remains the same. You still have the same substance. But when you have a chemical change, the chemical identity of the substance actually changes. You have a new chemical formula. Now, let's say if you have a piece of paper and you crumple it. Is that a physical change or a chemical change? Crumpling paper is a physical change. It's still paper. The substance is still the same. You haven't changed the identity of the substance. So that makes it a physical change. Now, let's say if you were to burn paper. If you took a lighter and you burn paper, the paper will eventually disappear. It will turn into carbon dioxide and water vapor. So in this case, the chemical identity of the paper is changing. It's changing into a new substance, into water and carbon dioxide. So burning paper is a chemical change. Now, what about freezing? Is freezing a physical change or a chemical change? So if you take liquid water and you put it inside your freezer and then it turns into ice, what type of change occurred? Is it physical or chemical? Freezing is a physical change. Freezing takes a liquid and converts it into a solid. Any type of change in the state of matter is a physical change. Ice is still water. It's just water in its solid form. So the chemical identity has remained the same. Liquid water has the formula H2O. Ice still has the formula H2O. So you haven't really changed the chemical identity of the substance. So if the chemical identity of the substance is still the same, then the only change that could have occurred is the physical change, not a chemical one. Now, let's say if you take water and you add electricity to it and it breaks down into hydrogen gas and oxygen gas. Is that a chemical change? The electrolysis of water is a chemical change. If you can break it down into its elements, then the chemical identity has changed. Hydrogen gas behaves completely different than liquid water. Oxygen gas is completely different than water. It's a whole new chemical substance. And so when you get a new substance from another substance, that's a chemical change. Now, what about burning gasoline? Let's say as you drive your car, you're burning gasoline. Is that a physical change or a chemical change? Gasoline is basically a mixture of hydrocarbons. And when gasoline reacts with oxygen and air, it creates carbon dioxide and water in a combustion reaction. So therefore, the chemical identity of the substance is changing. Gasoline, after reacting with air, turns into water vapor and carbon dioxide, which is a completely different substance than gasoline. So that's a chemical change. The chemical identity is changing. You can see that in the new formula that's being presented. So anytime something is burning, if you burn paper, if you burn gasoline, if you burn wood, all of those are chemical changes. You no longer have wood once you burn it. It's in the air, it's CO2 and water. Now, what about when iron metal rusts, when it corrodes and forms iron oxide? Is that a physical change or a chemical change? Any type of corrosion is a chemical change. When iron metal rusts, it reacts with oxygen and it turns into iron oxide. So iron oxide and iron are completely different substances. Iron oxide might be that orange-red rust that you see around iron metal on the outside. Iron metal conducts electricity, iron oxide does not. So it's a whole new substance, which makes it a chemical change. So any type of burning process, any corrosive process, that's a chemical change. So anytime something is reacting, if there is a chemical reaction, it will lead to a chemical change. Now, what about boiling? Let's say if you boil liquid water into steam. Is that a physical change or a chemical change? Boiling converts a liquid into a gas. Steam is still H2O, it's still water. So that's a physical change. Another example of a physical change is melting. Melting is the opposite process of freezing. Melting will take a solid and convert it to a liquid. So when ice melts into liquid water, that's a physical change. All you got to do is add heat to ice, and it's going to melt into liquid water. Now let's say if you have a beaker, and there's a red solution inside the beaker. And let's say in the course of 30 seconds or a minute, the color of the solution changes. Is this a physical change or a chemical change? In chemistry, whenever you see the color of a solution changes, it's because there's some sort of chemical reaction that's occurring. And therefore, a color change is associated with a chemical change. Something is reacting. And when something reacts chemically speaking, the chemical identity changes. So a color change is usually accompanied by a chemical change. Now let me get rid of a few things. Now what about vaporization? Is that a physical change or a chemical change? Vaporization is the process that occurs when a liquid turns into a gas, which is like boiling. If you boil water and you turn it into steam, you're basically vaporizing water. That's a physical change. Condensation is another physical change. So when steam turns back into liquid water, that's condensation. Sublimation is another word you want to be familiar with. Think of dry ice. Dry ice goes directly from a solid to a gas. So if you take dry ice and you put it on a table, it won't turn into a liquid. It's going to skip the liquid phase. You'll see gas coming off the dry ice immediately. That's sublimation. No wonder it's called dry ice. It doesn't liquefy, at least at normal pressure or atmospheric pressure. If you increase the pressure, you could make dry ice turn into a liquid. But at 1 atm, at sea level pressure, it doesn't happen. Now, there's another term you need to be familiar with, deposition. Deposition is basically the opposite of sublimation. That's when a gas goes directly into a solid, skipping the liquid phase. So if you take carbon dioxide in the air at 1 atm, standard pressure, and if you cool it down, you could freeze it back into dry ice. So anytime you have a change in the state of matter, it's a physical change. So anytime a solid is converted into a liquid, or a liquid changes into a gas, or vice versa, all of those changes are physical in nature. So keep that in mind. Now let's say if you have zinc metal reacting with acid. So it's being corroded by acid. That's another example of a chemical change. Any type of corrosion, whether a metal reacts with oxygen in the air in the case of iron, or if a metal reacts with acid and is corroded by it, that's a chemical change. Anytime something reacts, you have a chemical change. Now let's say if you take a piece of copper metal and you pull it into a wire. Is that a physical change or a chemical change? Taking a bar of copper metal and turn it into a very thin wire, that is a physical change. The wire is still composed of copper. Most metals are ductile and malleable. The ductility of a metal has to do with its ability to be drawn into fine, thin wires, which is good to make electrical circuits. And if you could take a metal and hammer it into sheets, that's the malleability of a metal. It's malleable if it can be hammered into sheets. So all of these are physical changes, just the same way as if you take a piece of paper and you crumple it. That's a physical change. You still have paper. Now what about when silver tarnishes? So when it loses its color and it develops that black tarnish. Is that a physical change or a chemical change? When silver tarnishes, the silver reacts with sulfur and it forms silver sulfide, which is blackish in nature. That's an example of a chemical change. The chemical identity of the substance is changing, and sometimes you can tell visibly based on the color change. Silver is turning black, so that's a color change which indicates a chemical change. So that's all I have for this video. So now you know how to distinguish a physical change from a chemical change.